50 essential chemistry concepts decoded for students worldwide. Whether you are prepping for competitive exams like IIT JEE, AP Chemistry, NEET, or your A levels, this video breaks down the exact high weightage fundamentals you need. We will cover periodic trends, quantum mechanics rules like the Aufbau principle, redox reactions, and metallurgy extractions. Watch till the end to master the subject. Let's start with a heavy hitter. This chromium extraction question using aluminium comes up again and again in exams like JEE and AP Chemistry. It's a classic filter that separates the top students from the rest. Ever wonder why H2O2 is never used as a solvent, even with its high dielectric constant? It's a tricky redox trap. Don't get caught out in IB Chemistry or NEET. Here's a classic comparison. Copper sulfate dissolves in ammonium hydroxide, but iron sulfate doesn't. Why? One complex formation makes all the difference in IIT JEE and AP Chemistry. Is potassium really more reactive than sodium? Yes. This periodic trend is super common in the SAT and MCAT. Master this logic, and you're instantly ahead. Now, think about acids. Why is HF a weaker acid than HI? The answer is purely about bond strength. It tests deep understanding in AP and IB exams. Speaking of foundations, defining orbital hybridization correctly is non-negotiable for IIT JEE and AP Chemistry. Get this right, and the rest clicks. Let's shift to atomic size. Why is sodium smaller than potassium? It comes down to a simple shell difference. You'll see this in CBSE and GCSE papers all the time. Here's a fact that surprises many. Fluorine actually has a lower electron affinity than chlorine. It's a frequent trick question in NEET and A levels. Want a quick hack? Oxygen usually sits at -2 and chlorine at -1. These default oxidation states are tested everywhere from the MCAT to CBSE. Moving to metallurgy. Carbon reduction for zinc extraction is standard textbook material for GCSE and A levels. But what about copper? It shows both +1 and +2 valency. This transition metal flexibility is a favorite in IB Chemistry and IIT JEE. Why must we use electrolysis for aluminium? Simply put, its oxide is way too stable. This is a high weightage question in AP Chemistry. Let's go back to basics. The Aufbau principle. This building up rule is absolute must-know territory for the SAT, NEET, and JEE. Switching gears to gold. The cyanide process is a beautiful example of coordination chemistry. Expect this in A levels and advanced exams. And while we're on metals, why do noble metals like gold, silver, and platinum never rust? It's basic, but globally important for middle school and GCSE science. Back to the periodic table. Atomic radius decreases as you move across a period. This is a core trend you cannot afford to miss in AP Chemistry or IB. Here's a great thermodynamics puzzle. Calcium fluoride is ionic, yet it refuses to dissolve in water. Why? Lattice energy wins. Watch out for this in IIT JEE. Let's do a quick calculation. The valency of barium, atomic number 56, is exactly 2. Straightforward, but it pops up in GCSE and SAT exams. Now, leaving the lab. Nuclear fusion, the clean energy that powers stars. This is a massive topic in AP Physics and Environmental Science. Back to chemistry. What makes a gas real instead of ideal? Understanding these deviations is crucial for IIT JEE and IB Chemistry. A quick history lesson. How exactly did Chadwick discover the neutron in 1932? This is a classic GCSE and CBSE question. Shifting to quantum mechanics. An atomic orbital is essentially a probability cloud. A key concept for AP Chemistry and A levels. Here's a practical question. Why is a copper sulfate solution acidic? It's all about hydrolysis, very common in NEET and IIT JEE. Next up, fundamental rules. The Pauli exclusion principle. Every chemistry student will face this in AP and NEET exams. Pairing that with Hund's rule for electron filling gives you the power to draw perfect diagrams for the SAT and JEE. Ever wonder why atomic number and valency are always whole numbers? It seems obvious, but it's actively tested in GCSE and CBSE. Let's test conductivity. Molten sodium chloride conducts electricity, but anhydrous HCl does not. Know this distinction for IB chemistry. Simplifying a big term, isotopes. They are just variations of elements. a foundational concept for the MCAT and SAT. Here's a weird trend. Carbon is a non-metal, but lead is a metal, even though they are in the exact same group. A great AP chemistry question. Think about the lab. Blue copper sulfate turns completely white when heated. It's a classic observation in GCSE and NEET practicals. Let's dive deeper into H2O2. If you forget why it fails as a solvent, the redox chemistry will trick you in AP chemistry and IIT JEE. Moving to nuclear chemistry, the group displacement law. It sounds complex, but it's highly predictable for A-levels and NEET. Back to industry. The extraction of zinc using carbon is standard metallurgy. Make sure you know the exact process for CBSE and A-levels. Here's a kinetic secret. Zinc dust reacts much faster than zinc granules. Why? Surface area. Every IB and GCSE student needs to know this. A mind-bending exception. Nitrogen has a +5 oxidation state, but its covalency is only 4. It breaks the normal rules, and AP chemistry loves it. Picture this. Heating lead nitrate releases thick brown fumes. It's a dramatic reaction you must memorize for GCSE practicals. Stripping it all back. What exactly is an electron? Understanding this basic particle is step 1 for SAT physics. Qualitative analysis trick. Copper hydroxide dissolves in ammonia, but not in sodium hydroxide. It's a classic IIT JEE and AP chemistry test. Real-world application. Why is magnesium used in flares and flashbulbs? Its incredibly bright combustion is a favorite general science fact in GCSE. Comparing gases. Ammonia is highly soluble in water, but phosphine is not. It all comes down to intermolecular forces for IB chemistry. Switching to physics. Alpha, beta, and gamma radiation. Knowing the exact differences between the three is core nuclear physics for the MCAT. And what defines an element in the first place? The proton. It's fundamental for SAT and CBSE science. Let's look at water. Why does it have such a high boiling point? The secret is hydrogen bonding, a key concept for the MCAT and IIT JEE. Back to electrochemistry. Why can we only extract sodium from molten sodium chloride? The reasoning is critical for AP chemistry. Don't confuse these two, mass number versus atomic weight. Knowing the calculation difference will save you points on the GCSE and SAT. A classic reaction. Zinc easily displaces copper in a solution. It's the ultimate reactivity series test for GCSE and IIT JEE. Theory time. What is metallic bonding? If you can explain the sea of electrons, you're ready for IB and AP chemistry. A brilliant redox puzzle. Copper reacts with HNO3, but it refuses to react with HCl. Can you explain why? IIT JEE expects you to. Final periodic trend. Metals and non-metals have completely opposite melting point trends across a period. A deep concept for A-levels and IB. And finally, why are metals electropositive? Understanding this core property unlocks their entire chemical behavior. Essential for GCSE and the MCAT. Which of these 50 concepts surprise you the most? Drop a comment below, tell me which country you are from, and I'll make more targeted science content just for you. Thank you.